Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of vectors as forces. So as per the problem, three solids of 5 Newton, 8 Newton and 10 Newton act from the corner of a rectangular solid along its three edges. So in part A, calculate the magnitude of the equilibrant of these three forces. So let's start with part A. So the first step is to draw a rectangular solid and show the three forces acting along its three edges from a corner. So let's assume the three forces are acting from the corner O, and we can label the other corners in this shape A, so let's assume the force of 5 Newton acts along the edge OA. The force 8 Newton acts along the edge OB, and the force 10 Newton acts along the edge OC. Now, we are given that the forces act along the three edges, and we know that the three edges at the corner of a rectangular solid are perpendicular to each other. That means side OA is perpendicular to side OB, and OA and OB are perpendicular to side OC. So we can assume that OA, OB and OC represent the three axes. So let's assume the x-axis is along OA and y-axis is along OB and z-axis is along OC. So that means vector OA can be used to represent the 5 Newton force, and vector OA is equal to 500, because if the force is acting along the x-axis, then its y and z components will be equal to 0. So there's a very important concept we need to understand and memorize. Now we can write the forces acting along OB and OC. So vector OB will be equal to, and vector OC is 0, 10. And now we have to find the magnitude of the equilibrant of these three forces, and we know equilibrant vector is equal in magnitude to resultant of forces or any other vector and is in opposite direction. So in order to find the magnitude of the equilibrant, we should find the magnitude of the resultant. So this is a very important concept you need to understand and memorize. Now the resultant of these three forces that act along the edges of this rectangular solid can be represented by the diagonal OE. So we have to write vector OE in terms of OA, OB and OC. Vector OE goes from point O to point E. So an alternate way to go from point O to point E is to go from O to A, then from A to D, and then from D to E. So we can break down vector OE into OA plus AD plus DE. Now vector AD is equal to vector OB because in a rectangular solid, opposite edges are equal to each other in length and are parallel to each other. Similarly, vector DE is equal to vector OC because in a rectangular solid, the opposite edges are equal in length and parallel to each other. Now we can use the three vectors we wrote for the three forces to find vector OE. Now we can add these vectors by adding their x and y and z components. So for x components we have 5, 0 and 0, so the sum is 5. And for the y components we have 0, 8 and 0 and the sum is 8. And for z components we have 0, 0 and 10, so the sum is 10. So this is vector OE, the resultant of the three force vectors. Now we can find the magnitude of this resultant. So for that, we have to square the components, add them and apply square root to the sum. Now we can evaluate the squares. So 5 square plus 8 square plus 10 square is equal to 189. And square root of 189 is equal to almost 13.75. And the unit is newtons. So this is the magnitude of the resultant of these three forces, and the equilibrant has the same magnitude as the resultant. Therefore, the magnitude of the equilibrant is 13.75 newtons. So if we use the equilibrant vector as E, so magnitude of equilibrant is 13.75 newton. So this should be the final answer for part A. Now we can analyze part B. Determine the angle that the equilibrant makes with each of the three forces. Now here we first have to find the angle that each of the three forces make with the resultant, and then we'll find the angle each of the three forces make with the equilibrant. So let's start with force OA, or the 5 Newton force represented by vector OA. So for that we need to analyze triangle OAE. And we should find the angle between the force represented by vector OA and the resultant OE, which is this angle here, EOA. Now we know the magnitude of force acting along vector OA, which is 5 newtons, the given force, and we know that the magnitude of the resultant OE is 13.75 newtons, and this is a right angle triangle. The right angle is at corner A in triangle OEA. So we can use SOHCAHTOA to find that blue angle, and we can use the cos ratio. So the formula for cos is adjacent over hypotenuse. The adjacent side is the magnitude of vector OA, and the hypotenuse is magnitude of vector OE. The magnitude of vector OA is the given force 5 Newton, and magnitude of OE is the resultant magnitude we found 13.75. Now we can do the inverse of cos. Now we can evaluate this cos inverse. So I got almost 68.7 degrees. So this is the angle between the 5 Newton force acting along vector OA and the resultant. Now we know that the equilibrant vector acts in a direction opposite to that of the resultant, and opposite vectors are 180 degrees apart. So to find the angle between the equilibrant and the force acting along vector OA, we should subtract 68.7 degrees from 180 degrees because opposite vectors are 180 degrees apart. And I get 111.3 degrees. So this should be the final answer for the angle between the equilibrant and the 5 Newton force acting along the edge OA. Now we can do the analysis for the other force acting along the edge OB. So for that, we should analyze the triangle OBE. And this is a right angle triangle with a right angle at corner B. And we have to find angle EOB, the angle between the force acting along the edge OB and the resultant OE. So for that we have to use the cos ratio again. And the formula for cos is adjacent over hypotenuse, and the adjacent side is the magnitude of vector OB. And the magnitude of the force acting along edge OB is 8 newtons, and the magnitude of the resultant is 13.75. Now we can do the inverse of cos. Now we can evaluate. So I got 54.4 degrees. So this is the angle between the resultant and the force acting along the edge OB. So to find the angle between the equilibrant and the 8 Newton force, we have to subtract 54.4 degrees from 180 degrees. So I got 125.6 degrees. So this should be the final answer for the angle between the equilibrant and the 8 Newton force acting along the edge OB. Now we can find the angle between the equilibrant and the force acting along the edge OC. So we'll start by finding the angle between the resultant and the force acting along the edge OC. So for that, we'll use triangle OCE. And this is a right angle triangle at corner C. And we have to find this angle here. So the angle between the resultant OE and the edge OC. So for that we can use the cos ratio, and the formula for cos is adjacent over hypotenuse, and the adjacent side length is represented by magnitude of vector OC. Now we can do the inverse of cos. So I got 43.3 degrees. So this is the angle between the resultant and the force acting along the edge OC. Now we can find the angle between the equilibrant and this 10 Newton force. So we should subtract 43.3 from 180 degrees. So I got 136.7 degrees. So this should be the final answer for the angle between the equilibrant and the force acting along the edge OC. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.